pandemic COVID-19, the story of UiTM Faceshields. All right. So before that, I would like to introduce our speaker, right? Associate Professor Dr. Muhammad Hussain Ismail. Okay, Professor Dr. Muhammad Hussain is a head of Industrial Linkage College of Engineering in University Technology Mara Shah Alam. He obtained his PhD from University of Sheffield, United Kingdom, and his research interest is on power metallurgy, metal injection molding, advanced materials, and material finding analysis. Okay, Dr. Muhammad also has supervised more than 20 postgraduate students and has published more than 60 articles at prestigious journals, seminars, and also book chapters. All right, so without further ado, I will invite our speaker, Associate Professor Dr. Muhammad Hussain Ismail, to give his lecture. All right, Prof, the floor is yours.
Bismillahirrahmanirrahim. Thank you, Dr. Linda, for your kind introduction. I would like to take this good opportunity to thank the organizing committees of this international summer course on humanities engineering, the role of engineers and scientists during the pandemic era. My name is Muhammad Hussain Ismail, and the topic of my presentation will be on the reimagining plastic during pandemic COVID-19. We'll be talking about the story of UiTM Faceshields. Actually, it's not really a UiTM Faceshields project, the one that we did last year during the MCO1, where we managed to produce about 42,000 pieces of face shield, and then we contribute to donate to hospitals and clinics all over Malaysia. So basically, the topic that I want to highlight for today's session is on the mainly on the plastic, reimagining plastic. So these are the outline of my presentation: the introduction to engineering materials. What do you know about plastics? Some of the concept of innovation from plastic, and innovation of UiTM Faceshields, and lastly, a way forward. Actually, this is my research innovation after completing my PhD, and then we collaborate with startup companies on the developments of the dental implant. So actually, I talk about the plastic and the dental implant, something that's totally different. So actually, this is my main research. So we are going to commercialize this implant, and currently we are in the final stage of clinical tests where there will be a total of 100 patients will be implanted with our first porous dental implant, actually the continuation from my PhD works. So when we talk about the MHI, stand for my name, Muhammad Hussain Ismail, Waste to Wealth project. Beside plastic, I've done some other waste material. For example, plastic and waste bottle. We turn it into a plastic product, aluminum cans, turn it into souvenirs. And before I did my PhD, I also did research on incinerator bottom ash, potential for the artificial aggregate, sludge paper ash for brick and artificial aggregate clamshell. My master student did this on the synthesis of this clamshell, and as a bone substitution. Besides that, there are also research on the eggshell, M3 food bun ash for bricks and sawdust. And some of the outcome of the findings we published in some of the technical papers and in local and international conference proceeding. And then a bit about innovation, because my topic will be a bit about an aspect of innovation. How do we want to nurture the element of innovation by creating values out of this waste from plastics? So innovation, why it matters, is driven by the ability to see connections, to spot opportunities and take advantage of them. And it is not just opening new market, it can also offer new ways of serving established one. For example, the one that we are having right now, our session, if there's no pandemic, maybe a summer program will be in Indonesia. But now, thanks to the technology, we still can communicate, we still can have seminars through webinars by having this platform like a Google Meet, YouTube, Zoom, and WebEx meeting. And now if you look, almost everything For example, Netflix, you can watch 24 hours non-stop, any movies, right? So these are all these aspects of innovation. So basically, when we talk about innovation, it can be divided into two aspects. Either it is a product innovations, or the second one is a process innovation, improvement of the process towards lean process, minimize waste, or reducing waste towards the process activities. So basically, innovation is not only on manufactured product, it also process innovation also can be considered as a part of innovation. And then when we talk about innovation, it's actually a symbiosis between the creative organization and the creative people that produce innovation. So actually, if you look here, the ecosystem of the innovation start from the ideations, then when you define it, and then how you to design, and then for the product developments, how they want to secure the ideas through IP, intellectual properties, and then it depending on the acceptance of the society towards the ideas of innovations. So basically, it is symbiosis between the creative people and creative organization that produce innovation. And it is an interplay between the individual creativity and environmental creativity. And these are the driving force of innovation in any organization, regardless the levels of innovation, whether it's small or big innovation. This is the most important elements where we need the creative people, creative environment, and creative organizations. When we talk about because this my main area is materials engineering. So it's a bit about materials. I believe that all the participants come from different background. So basically, materials engineering can be classified into three main categories. The first one is metals, that one that I'm really my majoring, and then the second one is ceramic materials, and the third one is a polymer. So any combinations of two material considered as a composite, and metal mixed with the ceramic, it become composite. When metal mixed with the polymer, become composite. Either the metal become matrix or the ceramic become composite. The ceramic become metric. It depends on the final applications of the product that we develop. So these are some of the examples of the metallic material being used. Just to show you the example of the implant, the dental screws, and the turbojet engine. It consists of materials, high-end material. So different components have a different purpose and applications. For example, for the implant, normally we use titanium alloy owing to the extraordinary properties of this titanium. And for the turbojet engine, it requires that the material can withstand very high temperatures during the operation of this jet engine. And then for the ceramics, these can be classified into two categories. The first one is traditional ceramic, as can be seen here, and also industrial ceramic, which is the components a little bit precise compared to the traditional ceramic. And then the polymers, actually, these are the things that I want to highlight for today's lecture. So basically, polymers, if you look here, okay, these are the bottles which are categorized under the polymeric materials. Then for the composite, these are the example of the carbon fibers, which have the combination between the raw materials of the metal, ceramic, and polymers. Right. Let me narrow down on the plastics. Okay. Did you know? I believe that when I show this image, everybody know that all these bottles, right? Regardless the colors, but all of these are bottles. So 100% of plastic can be recycled. Okay, 100% of plastic can be recycled, but most people recycle 50%. But it depends. Some of the countries, they have an initiative towards these recycling activities. The ecosystem of recycling have been nurtured among the communities. But some countries, they still got problem with the lots of waste dumping on site. Okay, then we familiar with the terms 3R: reduce, reuse, and recycle. So basically, it reflects the different aspects of how we manage the waste. Okay, and so these are some facts and figures. Did we aware about the waste recycle, and do we really practice it? For example, at home we have many plastic parts, okay, shampoo bottles, yogurt drinks. There's just so many, and even the toys. As some of when your kids you play with the Legos, right? So all of these are plastics. And the average from the standpoint of Malaysia, these are the data based on in 2014. The average Malaysia throw away 1.6 kilogram of waste per day, which above the average worldwide at 1.2 kilogram, according to the World Bank report. So if we refer to the countries like Germany, it has demonstrated the exercise the recycling activities about 66%, and the neighbors of Malaysia, Singapore, practicing recycle activities about 57%. However, in Malaysia, we only practice recycle about 11%. So basically, where the other 89%. So that's why today's lecture is a very good platform to share with you some of the ideas of innovation, how we can turn this plastic into something that have values. We believe that all of you are familiar with all these kind of bins. So different bins have a different designated materials. For example, the blue colors, the green colors, and the yellow colors for the different types of waste materials. However, one of the big issues, the awareness among the society, they do not know the designated bins. They just throw everything inside one bin. For example, here, even though that it has the logos for the ceramic glass, but you can see what is inside this bin. So this is one of the big issues in Malaysia. I believe that in some other countries we're also facing this. So then level of enforcement is not really we can see. Okay, so that's why the level of recycling activity is still low in comparison with other countries. Right, let's have a look. Okay, I believe that all of you are familiar with this. The left-hand side is the food container, and the right-hand side is the detergent bottle. And you have a look the numbers. Okay, the numbers stem on the bottoms of the bottles or the food containers. So if you look closely, it shows that for this food container, it has the numbers. Number is that, okay, is a PP. And then the second one is number 2. Stated here is HDPE. Okay, then. So these are basically the ecosystem of the plastic. Okay, when it is sent for further processing, and then when you throw out or when you send the plastic to the recycle center. So this actually happened, okay? The ecosystem of these plastic materials. So these are one of the big issues, okay? Our global issues. You can see here the plastic in the ocean, where we can see that commonly found plastic like single-use plastic, beverage bottles, and beside that, the straws. So these are the one of the big issues facing many oceans, and the problem is the problem of the entanglement and ingestion of, for example, here the turtle when they consume this the plastic, they give a severe to the inside body of these ocean creatures, right? These are microplastic. Then the source of the plastic come from the streams and the storm drains. Then when we look at the all of this kind of waste, okay, it takes time to decompose. For example, if you look to the plastic bottle, it takes 450 years. The one that we consume, okay, the mineral bottles, it takes nearly 500 years to be completely decomposed. So if you look others, for example, train ticket about 2 weeks, orange peel about 6 months, milk cartoons about 5 years. So I just want to highlight on these plastic bottles. That's why all countries they really emphasize to ban the use of these mineral bottles because of the decompose degradations of the material is more than 500 years. There's another image taken from the internet. The plastic takes to break down. The estimated decomposition rate of plastic in our ocean. For example, the detergent bottle that I shown just now, the numbers of HDPE, high density polyethylene, it takes about 500 to 1000 years. And the soda bottles, PET, it takes about 450 to 1000 years. So just imagine these two types of the plastic. Okay, so we already pollute the environment. As engineers, we have to find an innovative measures to reduce the problem faced by the earth. Okay, so using our brain and the knowledge that we learn in the universities, we can turn this plastic into something that can have values. Right, so let's moving on these numbers. We believe that you know about these numbers, but in many cases when I presenting in front of the participant, many people get these numbers wrong, the perceptions. Many people say that this number reflecting how many times the material can be recycled. That was totally wrong. Number 1, number 2, number 3, number 14, number 7. So basically, these numbers reflects the code for this particular plastic. For example, number 1, which can be found in our mineral bottle, PET, HDPE, high density polyethylene, V, vinyl, LDPE, number 4, number 5, polypropylene, number 6, polystyrene, and 7 is a combination of all types of the plastic. So in this sharing, I will be focusing mainly on 3 types of polymers, which are HDPE number 2, number 4, and number 5. Right. So these are recent identification code, which is developed by the Society of Plastic Industries (SPI) in 1988. The purpose of this RIC is to allow the ease of separation, so you can easily to segregate the material according to the type of plastic, of different type of plastic for recycling purposes, and also tell the users on what type of the plastic there are, how biodegradable the type of plastic used, and the safety aspect of using this plastic product. So these are some examples. Okay, you can get it from internet. Okay, the description and the information for different type of recent identification code. Number 1, number 2, for example, high density polyethylene found in milk and juice bottles, motor oil bottles, bleach, and detergent bottles. And number 3 is polyvinyl chloride found in medical equipment, piping, and clear food packaging. Number 4 is LDPE, low density polyethylene. So these are the recent identification code system. Okay, so the triangle refers to the material that can be recycled. There's another polymers, which are polypropylene, found in some yogurt containers, syrup bottles, and medicine bottles, polystyrene, disposable plates, all other resin and multi-material. So it has the combinations. So it belongs to number 7. I believe that all of you are very familiar with these 3 are reduce, reuse, and recycle. In my topic, mainly will be on the recycle and a bit about upcycling of the plastic. So for the reuse, it's very easy. So just reuse the plastic components or any kind of waste for the different purpose. And these are the another applications where we can reuse these, for example, this detergent bottle. We cut off for the ear guard to hang the mask. Reduce, basically something that you're not use it, we just send it to the recycling center. So we just use the only part that you want to use. So there's another aspect between the recycling and upcycling. So basically the concept of recycling and upcycling from the aspects of environment, where both conserve the environment. But what actually the values that we can get from the upcycling, where it reform a product into a new product. Okay, for example, when we have this kind of waste and we turn it into another new product which has values, which is have unlimited available usage of raw materials. Okay, from the standpoint of the qualities through the upcycling, the part will have a better quality. Design is very unique when you are very when you have and we have a design unique and handmade and limited edition. So these are some examples of the product which can be go through the upcycling. So for the recycling, basically we use the same material and then we turn it into something, but it is 100% from the recycled material. So in order for us to understand the concept of recycling and upcycling, because it involves the use of machines. So as engineers, we should know what are the important parameters. What are the important parameters? For example, if you want to recycle it, what is the optimum temperatures to be used to recycle them? So these are some of the important attributes either for recycling or upcycling. The thermal analysis play a very important role. This figure shows two graphs showing the first one, figure 6, is a differential scanning calorimetry, showing a different peak representing a different melting temperatures for different waste polymers. What you can see here, the blue curve indicating the high density polyethylene which melt at the temperature of 134 degrees Celsius. And the polypropylene has a melting temperature slightly higher, around 165 degrees Celsius. And if you look to the PET, this one is a material from a mineral bottle. It has a very complex curve showing a different melting of the materials when it is heated up to 400 degrees Celsius. Another aspect of thermal analysis is the degradations or decompositions of the materials. So if you want to know what is the decomposition of the material and what are the residue as a result of burning out of these materials, so this TGA can be used, thermogravimetric analysis. So if you refer to this one, it can be found that the blue and the red representing the HDPE and PP decompose almost complete. It has the remaining in the form of ash, about less than 5%. However, for the PET, it has the remaining compound about more than 40%. So these are one of the critical issues for the PET consideration from the standpoint of thermal behavior. Another aspect is the flow analysis. So when we talk about the flow analysis, when we apply temperatures on this plastic material, the viscosity will change. As the temperature increases, the viscosity decreases as functions of temperatures. So this figure shows the correlation that exists between the viscosity as a function of shear rate at various temperatures. For example, this one is a rheology of 3D printed waste. We studied about the two different types of material that's commonly used in 3D printing. I believe that maybe some of you are familiar with 3D printing. The filament, normally the temperature is set had the temperatures of 180 to not more than 250 degrees Celsius, depending on the materials. So for example, PLA waste, it's found that at the temperatures of 180 to 190 degrees Celsius, we can see the similar trend. The viscosity is not really high, about less than 100 Pascal second. But when we compare with the ABS, that's why ABS is quite tough for the application that requires certain strength. The viscosity is quite high, almost 100,000 times than the viscosity for the PLA. And the pattern looks like the same, but the level of viscosity is much, much higher for the ABS. So these factors is very important. If let's say that you want to recycle, then you want to process it, you want to process for the other applications. So these are some of the ideas of plastic making. Sometimes we got the ideas from a very simple things that we see every day, right? Like this one. I believe that all of you familiar with this. This is muffle maker, right? It's a muffle maker. So if you look to this muffle maker, the concept of this muffle maker, they have important parameters where we have to set the temperatures. We have to set the temperature. What are temperature to be set? It depends. So for the wafer, I'm not really sure because I just know the concept. That's very simple analogy in the process of making plastic using this concept of wafer maker. So basically in the wafer maker, we have applied temperatures, probably I'll say about 100, 150 degrees Celsius, and then the pressure will be applied, okay, until we get the desired wafer, right? And these are some of the examples of the plastic, how it can turn from the waste plastic into something where we apply the concept of compression. So we got a very nice image of the block here representing the different colors of the plastics. So what we need to do is to control the parameters of temperatures. That's why it's important to know what is the melting temperatures of this polymer. So if we know that the melting temperature is 140, so we need to apply temperature of 140 so that the plastic turn into molten materials. Then voila, this is the shape, and the colors depending on what types of the bottle that we use. Right, in the engineering, manufacturing, the concept that we got from the wafer maker, we have this machine, which is called a compression molding. The concept is similar to the wafer maker, where the plastic material is placed inside here, okay, the mold and the patterns, and then the heat is applied in order to melt the plastic, and then it will be shaped depending on the pattern that we have designed. So in order to get the product, we have to think something out of the box. So these are some of the project done by my final year project student 5 years back. We want to blend the concept of innovation. So if you look here, the student can learn something which is out of the box. Of course, students from engineering, we are not going to focus on the literature of this Islamic calligraphy. This, I believe, for the students in Islamic studies. But we want to have this blend of, thinking out of the box, how we can craft something which have the values which is up of the things that we commonly study in engineering. At the same time, we can appreciate the values that we integrate in the concept of innovations. And the students, they learn about the literature about this, for example, in this case, the history of Kufi calligraphy. Okay, for example, here the Elias Kufi, and then Eastern Kufi and the Square Kufi. And how do we want to integrate the concept of this innovation to the ideas of recycle? Right. Let's have a look at this. Right. So if you look here, this you can see a very unique Kufi calligraphy. Okay. So as engineers, we should think out of the box. We're not only thinking as an engineer, but sometimes we have to think in the creative aspects. Right. Then we discuss turn into something that for example, here, the words is not like the Allah Muhammad, but we turn it into the word which is mechanical, because we are from mechanical engineering. So we use this word mechanical. This one is mim, ya, kaf, nun, ya, kaf, lam, mechanical. It's from here, kaf, nun, ya, kaf, lam. It's the word mechanical. Right, now, how do you want to turn it into a product? So basically, use the concept of the hot pressing. We have a mold and pattern. We have mold and pattern, and then we crush the plastic. And this one, the aspect of innovation, where the student learn about the engineering. They have to design, that they have to come up with the parts. So this is the mold and the pattern, and then go through the engineering process, the manufacturing, burst formation, then we clean up from any marks, okay, and then this is a final process, and we got this a finished mold and pattern. So what's next? So we use the concept of the one that I shown just now. Use a different plastic. So, but before we proceed with this one, we need to know what is the melting temperatures. For example, here HDPE, high density polyethylene. The melting temperature is about 134 degrees Celsius. Therefore, during the compression, we need to apply 134, a little bit slightly higher than that one, in order for the pelletized plastic will be melt. Okay, and for the polypropylene, we segregate this plastic first. The first one, high density polyethylene, mainly from detergent bottle, polypropylene. I've forgotten where the student got these materials. We segregate because have a different melting temperatures. We have tried many times for the PET, but unfortunately, most of the part we got problem. So this reflect the thermal behavior that I shown just now. Okay, we have several peaks for the PET, and this is the final product. So if you look here, the finished process, they have a different colors depending on the what type of the colors of the bottle that we use. This one, for example, black colors. We have white colors. We have composite colors. You know, it's very unique, like a tie, but it's a polymers. I believe that all of you very familiar with these two big product. The first is Lego, and the second one is Tupperware. Right? I believe that all of you have a set of Tupperware, at least one. And the Lego is a famous toys when we were kids. Maybe some of you still have these units, and the plastic block, which is made of the this plastic material, which is PP. So what actually the things, these are the things that actually use the concept of what we have learned in the process of making this the container, food container of this plastic. The concept is still the same. We need to know what is the temperature used. And then, of course, in the engineering aspect, the pressure that apply during the process. So basically, just to highlight, these are the product that we see every day, that we use every day to store our food, okay, inside this container. So the second process is injection molding. Okay, the first one that I highlighted is compression molding. The second one is injection molding. It's a process of forming an article by forcing molten plastic material under pressure into a mold where it is cooled, solidified, and subsequently released by opening the two halves of the molds. So these are the example of the product that can be produced from this injection molding. We have the feed hopper, heaters, barrels. So we carry the molten material, and then the pressure is applied to the mold cavities to get the desired shape. Okay, these are the example of the mold of the Tupperware and also the Lego. It is a mold, there's a mold opening, and then the part will be released from the cavities. Right, so here's another one. Okay, from the ideas of Hut Hufi that I highlighted just now, actually we have two students during that time. The first student emphasized on the hot pressing, and the second student focusing on the injection molding. We just use a very simple injection molding, and the student managed to produce some amounts of the part from the recycled plastic. And the concept of engineering here, that the student can learn the location of the gating so that we get the good locations of the injection. So this simulation shows the temperature gradient as a result of different gating points, right? So gating point is reflecting the location where we put the gating point here. So these are the coffee calligraphy using the injection molding, mold and patterns. And these are our final product, which is from the recycled plastic from the this kind of bottles. And these are the machine that we have. It's very small machines that the student managed to produce this keychain. Okay, this one from the polypropylene, and this one is lubricating oil. And this is the one that we have the big scale injection molding in our lab. This is 120 ton. It's a semi. It's considered as industrial scale, but for the small parts, not really for the big parts. 120 ton. And another aspect of innovation that from my final year project, through this bringing some of the elements. For example, here how do you want to make another innovations? For example, here Malay Kris, right? It's a short weapon used over 600 years. Malaysia, Indonesia, we know that it's a kris used for self-defense and as a royal instrument, and also a symbol of sovereignty of Malays, okay, Malaysian and Indonesian, right? These are the symbols of sovereignty of Malays. And for the UiTM logos, you can see that the two cross kris symbolize the sovereignty of Malay kings and the struggle of the Malays to uphold the excellence and sovereignty of the nations. And through the final year projects, the kris and bookmarks, okay, we create from the concept, still the concept of recycling of the plastic, but we turn it into something else. This one is example of the kris bookmarks, bookmark, and also the bookmarks. And this is a process of machining. The student have done the simulation and the location of the gating until the final process of manufacturing of the pattern of the mold. And we have used for different occasions, like for example, souvenirs for different activities. These are some of the examples. And also this our CSR, where we support F1 in schools, souvenirs for the aero team for SMK Section 9, one of our partners where we support in terms of innovations. This one is last 2 years, okay, where they have activities in Sarawak, Borneo Jazz Festival, and they have a campaign on recycle project. So we contribute in terms of souvenirs to them. So the another activities is we see that the potentials of this plastic, not only from the bottles, but I do believe that when in the universities, students' chairs made of plastic materials. So these are one of the big issues in our faculties. There are so many broken plastic chairs. So if you look at these broken plastic chairs, it is polypropylene, and we take it as a student for the final project, and then we study about the flow and thermal behavior before we proceed with the injection molding. So these are the product. The student managed to produce about 1,000 pieces of this card holder. This student did this project, and these are the different colors representing different types of the material that we use. For example, these brown colors is from a single broken plastic chairs, and these colors were from the detergent bottle, and this one from the detergent bottle. So just imagine that These are the pattern of the mold. We have the logos of UiTM as well for this card holder. And the student did some simulation because you want to know what are the best operating temperatures and what are the best pressures before actual injection molding was done. So by doing this, we can predict what is the optimum parameters of temperatures and pressures during the actual injection molding. And we managed to get the gold medal during competition of innovation competition last 2 years, 2018. We call it Mackie card holder from the waste plastic. All of this 100% from waste plastic. And from this project, beside we recycle, we create awareness, particularly to the participant, and to give their some insight on the what we can do with all these kind of plastics. And beside that, we also managed to contribute to Pusat Asasi UiTM, where we sell about 2,000 pieces Pusat Asasi UiTM Dengkel in last 2 years. And then beside 3R, okay, we also apply 7R. Maybe some of you still knew about the 7R. Instead of 3R, reduce, reuse, and recycle, basically towards sustainability activities and towards 17 sustainable development goal. So we have to apply this concept of 7R, where we have to retain, refuse, decide, reduce, reuse, and recycle, repurpose, recycle, and road. So in order to understand why we need to do 7Rs of sustainability, we need to first understand the life cycle of the things that we buy. It all starts with harvesting natural resources and transforming them into goods. Then we sell them, use them, and throw them out. This all business as usual. But is it really the best way? And one clear problem with this process is that it has a beginning and an end, but with only one earth, with the limited amount of resources, we cannot always be making more things and throwing them out. And that is where the 7Rs come in. And if you look to the ecosystem of the 7R, refuse, reduce, refuse and reduce. So when we refuse and reduce, we eliminate the needs to produce the item in the first place for business. So there's no demand, means no supply. So when we reuse, repair, and repurpose, we extend the life of that one item. And then for reuse, only need to buy one and the items, and only need to buy a new one. And then if we talk about the recycle, this is the one that I've shown just now, and that's actually the main topics of this sharing. And talk about the ROT. ROT is actually reflecting composting. Biodegradable material decompose, allowing the nutrient to return back to the earth. Okay, so these are the ecosystem of these 7R that need to be nurtured among us. So beside the innovation activities, basically one of the most important aspect, how we can create values, the values so that the society know the impact. So this is the one that I want to share with you, that the impact of the recycling awareness we share with the student at school, and the student do the activities. So this is one of our, we mentoring the students F1 in school in 2017. And the group of students representing Malaysia won Innovative Thinking Awards out of the ideas of recycling, where they collect the water cap, and then I prepared for the mold, and the student came to UiTM, did injection molding by themselves. Just imagine that student of Form 2 managed to do the injection molding by themselves. So this is a part of our CSR activities, how we engage with the communities. We open our lab, okay, so that they can experience something out of these waste materials. And beside that, we also do the activities reach out the communities, giving the awareness about the recycling activities out of this plastic. And besides that, some of these activities sharing, these are some of my activities last 2 years, and sharing session with regard to this plastic, reimagining plastic. And these are some of the activities done by other lecturers in our department, with the concept compression, and these are the ideas of interlocking bricks. And there's another lecturers who did the construction material using all this kind of waste materials. When we talk about this, I believe that all of you familiar with this. Talk about 3D printings, right? So when we talk about 3D printing, especially students from engineering, they want to produce customized parts. They manage to produce their design, then how they want to get things printed. Traditional way we have to do, for example, by injection molding, which is very costly in terms of the mold. In this case, 3D printing now become cheaper and cheaper. And even you can get less than 1,000 ringgit for 3D printers. So if you look to the printer, the source is the filament here is a plastics. Sometimes, when we do printing, of course, some of the parts we need to throw it away. So by having the ideas of innovation, so we can have a great ecosystem of this 3D printing. So if you look here, all of these are desktop one. I got this image from the internet. This one is 3D printers. This one is a laptop for design. Then when we have confirmed with the design and we do printing, but sometimes there are some errors, right? So we need to throw the printed parts. So actually, the waste from this can be recycled. Okay, using this machine, we crush it and then turn it into filament, and then we use it again. Okay. So these are the green technology. So we reduce the waste as a result from the process. So these are 3D printers. The material normally PLA or ABS, and these are the extruder machine. Very simple, small, compact one. So you can see that the ecosystem of this 3D printing. Another one aspect of the material of PLA, which is considered as biodegradable. Now there are quite many researchers. They are trying to develop the PLA from the waste material and improving the properties of this PLA to be used in a different application, such as in biomedical application for implant, because this PLA is biomaterials, and besides that, it has a very, very minimal the decomposition time as comparison with conventional plastics. So this is one that my final year project student last 2 years, we try to produce a filament out of this waste structure from the 3D printers. So we got from 3D printing companies, and then we crush it, and then we study about the material behavior, the rheology, the thermal behavior, as well as the mechanical properties. Because as a student or lecturers on mechanical engineering, we also need to know what are the mechanical properties of this material that we produce. So this figure show the one that we produce using our small machine, and then to compare the result between the mechanical properties between the this one is a virgin material, the one that we buy from supplier, and then this is the one that we recycle. Okay, from the standpoint of mechanical behavior, it's not much different, but yeah, the virgin one has a better mechanical strength compared to the recycled one. But in terms of the strain level, it's almost the same. But in terms of, this need to be further improved for time to time by doing research, innovations, and looking forward for the much better properties of the filament. Right. This basically actually the one that I want to highlight. The story behind the face shield is actually about the recycling, about the materials, about the injection molding, about 3D printing. So when we talk about this face shield project last year, we managed to produce about 42,000 pieces within 2 months. Just imagine that, within 2 months. So there are two important technologies here. The first one is 3D printing, and the second one is the injection molding. So basically, when we talk about the, I believe that maybe some of you heard about during the MCO1. So many hospitals need face shield. So Malaysian 3D printing and design communities are coming together to produce face shield for frontliners facing the COVID-19 pandemic. So be face shield in short supply. So these communities of 3D printers, all the community of 3D printers come up with the ideas of innovation, the different set design of face shield frame. And at the early stage of our innovation activities of project CSR, we started with 3D printing. First phase where we have some numbers of 3D printers, and then we did meeting, and then we brought home all the 3D printers, as can be seen here, the different location, residential areas, location. This one different depending on the locations of the staff. Okay, in Sementar, MPCTTDI Gadjah, PP Perdana, Section 7, Section 13, Padang Jawa, AA3D Jaya. Okay, so with the 3D printing units. So if you look here, the number of 3D printing, for one single 3D printer, we can only produce one day, I would say maximum of not more than 15 one day. So this is one of the limitation. So single face shield, we managed to produce about half an hour, only one. So this is one of the big issues on the 3D printing. It is time consuming, and in 1 week, in a few days, we just managed to produce only 200 to 300 pieces only. Just imagine that we have 16 number of 3D printers. We only managed to produce about 107 number of pieces. So this data as 25th of March. We started in 23rd of March. So this during 2 days, we managed to produce about 107 number of pieces. And then during the we discussed through the WhatsApp group. There are also a group from injection molding. Okay, I'm doing the injection molding. Why not we do the injection molding? We have the machine. Okay, we have the capability, and yeah, let's do it, right? Because we have experience using this injection molding, the mass production by injection molding, using this UiTM data scale. So we have experience using our cut holder. We managed to produce 1,000 pieces per day, okay, by the students, right? So just imagine by using 3D printers, how long does it take to produce the 1,000 pieces, right? So just imagine the time consuming, the energy, right? And the consumption of electricity. So the third phase is through the injection molding, the one that we use for the craze, for the cut holder. And now we have this injection molding for this one. And CNC of injection molding, it takes about 3 days. This is a breakthrough in our record, making this mold within 3 days. We got problem in getting some parts because all the hardware were closed, and alhamdulillah, we got good collaboration with companies that managed to get some of the parts. For example, here you can see the spring here. So actually, this spring was supplied by the company. Gaia Plus supplied the company, supplied with the spring, and some of the screws that are not available in our lab. They got it for us to complete this mold manufacturing. These are one of the tweet kita jaga kita. I've forgotten when is it. Inject ideas on execution, March 26. So these are some of the group members. So this is actually the 3D printed parts. We got the idea. Probably you can do the injection molding. It's doable. It was doable. And the mold fabric modification, March 27, we did some modification of the mold. It never been done before. And the first mass production completely within 3 days in March 30. Okay, you can see here, we can produce for the first days, we managed to produce 700 pieces and at least 700 pieces per day. So this is our process flow system. Some residential units, they're focusing on 3D printing, some focusing on the design, some did the simulation, and at the same time, some other group focusing on the injection molding. And these are the our recipients of face shield. We supply more than 300 hospitals and clinics entire Malaysia. And these are the our frames, and this our delivery location. Okay, we highlighted through this dashboard the location of the recipients of facial. Then this is a close-up view of the area Klang Valley, and it's our collaborators. We have Petronas, Gadjah, Highcom, who are working with us. We leveraging the collaboration with the companies and leverage collaboration. The Petronas, our main sponsors of the raw material, we receive 1 ton, 1,000 kilogram of raw materials of polypropylene from Petronas. During the first time, we got 250 kilogram, and then followed by another 750 kilogram. And we're working closely with the companies, for example, 3D Gens, Highcom Taxi. So these are the collaborators. And this are the way how we donate to schools, facial donation to schools. Then beside that, we have file IP, and it already granted copyright on the design, because the design we cannot say that is our patent, because this one is actually open source, and we did some modification on the aspects of the facial frame, and then we did a copyright, and all the members who involved have their name here. Right, so we acknowledge all those who involved in these CSR activities. And of course, for the media coverage, we got quite numbers of media coverage from the beginning of this project till the end of this project. And beside that, we managed to organize a few events. For example, MOU signing ceremony with UiTM Gadjah plus Berhad. This event was the first time MOU event during MCO1, the first company that have a MOU during this event. And then the second time, within a few weeks, there is a licensing agreement signing ceremony between UiTM, Gadjah, Pebble on 28th of May. And there are some photos, sponsorship of facial together with the CEO of Gadjah Plus, Mr. Qayyum, and the director. And these are the appeared on the Bulletin Utama TV3, where collaboration between Gadjah Plus and UiTM. And beside that, we also we're not competing with others, because as there's a part of our CSR, we are not competing, we are complementing. We got from Petronas, email from Petronas requesting our design. Actually, we just share our design, and Proton did by themselves. They have vendors on injection molding, so they managed to produce injection molding. They have, of course, they are their main business. Ours from the universities. UiTM is among the first who did the injection molding of facial during the pandemic MCO1. All right, at the end of my sharing is a conclusion of my sharing. Way forward, creative mindsets is very important tools in the process of innovations, which leads to new product and processes that sustain our economy. Sometimes for having this creative mindset, we need to think out of the box. For example, some of the project of the for example, FYP, final year project, how we want to integrate the concept of something that never learned before, right? And then there are room for the integrations where we can craft something. We blend the ideas of engineering, we blend the ideas from the other aspect, for example, arts. And plastic are too valuable to throw away, turn it into wealth. So that's why when we consider about the aspect of turn into wealth, the ideas of innovation, what are the resources that we have, the capability. For example, in our faculty, we have machines, we have resources, we have manpower, we have expertise in this field. So what need to do is to find a good approach. So how do you want to create values? Creating value is something that is very important, particularly for students, because when the students are graduating, you will be competing with other students from various backgrounds. So when we do the final year project, my students who are doing in the final year project, some of them, they collaborate with companies, collaboration with industries where the project is from industries, and how do we use our capabilities, our strength to help or to facilitate these industries. At the end, the outcome, it will be used by industry. It will benefited by the industries. Beside paper publication, actually the most important thing is how we can create values out of our resources, for example, from the final year project, and apply 7R instead of 3R. Rethink, refuse, reduce, reuse, repurpose, and recycle. Recycling is one of the strategy for end of life waste management. So if we manage to do this recycling of this abundant plastic waste, inshallah, there'll be a lot more ideas of creating values towards these activities. And last but not least, as a human being, okay, Khalifah on this earth, everybody should take a role as an agent of change, regardless of our background. It doesn't mean that you need to be from mechanical or engineering background that you need to be do the recycling activities, right? So me as a lecturer, we have to think something that can give opportunities toward the society, towards a better ecosystem, and of course sustainable of the activities from the project. I think that's all from me. Thank you very much, and I'd like to pass to moderators.
Okay, thank you very much, Associate Professor Dr. Hussain. Okay, it's a very interesting sharing session. I myself learned a lot from this sharing session. Okay, even I myself, I'm not from the engineering background, even though that I specialize in solid waste as well. Okay, but I'm more on the management side. All right. So from my aspect, okay, normally what we'll do is that we will find ways on how to inculcate awareness to the public, right? And how are we going to manage whatever waste that is produced in Malaysia? But in terms of engineering, all right, we can see there are many innovations that can be done, especially from the mold and injection patterns. We can produce innovation products such as calligraphy, bookmarks, face shield, and also keychains and key card holders and more, right? So this is a very that means what is like when we have waste, right? Is normally people will say waste, they look at waste, they will say it's very smelly, they tend to look down on waste, right? But you see, actually from waste, we can actually become wealth, all right? Not only we can manage the waste, we can try to clean the environment, but we can also make money out of it, all right? So that's why we need to have a new mindset on how to look at waste and manage them. Okay, and another thing is that I also agree with Prof. Hussain saying that actually there are 100% of the plastics can be recycled. All right, there are 7 categories of plastic, 1 until 7, but we only recycle certain types of plastics only. Okay, because sometimes we find because the recyclers, there are some plastics that are easy to be recycled and some are a little bit difficult and need more costly. All right, so even in Malaysia itself, we only recycle type 1, 2, and 5 category of plastics. Okay, so maybe the other plastics we can actually try to innovate them. Okay, since that we know that now that through this in molding and injection technique, we can produce so much more. Okay, all right. So is there any questions from the participants that you would like to ask or you want to share with the speaker? Okay, at the description box, there is an attendance link. All right, so please fill in your attendance form for this session. Okay, is there any questions that you want to ask?
Yes, Doctor. Assalamu alaikum. Well, I just want to ask a question about your opinion or view on effective method of recycling that you think can be adopted in recycling most of the waste that we have from different sources, maybe solid waste, maybe agri waste, and other maybe like the household waste. What are the effective methods that you may suggest or think that can be used for individual recycling or joint recycling method? Thank you.
All right. Thank you very much for the questions. Yeah, recycling is one of the big issue when we talk about the different type of the materials. So just now I'm talking about only plastic. So almost everything, all the plastic can be recycled according to the numbers. But actually for the different household, for example, non-plastic material, how it can be recycled. Actually, some of the countries they have implement the different ways of recycling. For example, in Japan, they have a different type of bin, different type of the bin, and then different bin collector. Different day we have a different different people we collect the different type of the waste bin. For example, when I was in UK, for every week there are in every week there are a different dustbin collector. Okay, there are only 2 bins. There are only 2 bins. One for the papers and all this plastic, and then the second one is common waste. For this plastic and this kind of recycled material, it will be collected twice a week. And then in some cases we have a recycling center. In Malaysia, there are quite not many say that very few recycling center. Some they are really good, they are managed properly, but some can be seen that the people surrounding, they do not know how to manage these kinds of this waste. So that's why awareness throughout the community is very, very important. Even though that council can provide this recycling center, but the enforcement for the effectiveness of this recycling is one of the great concern, and this must be the cooperation not only from the public council, but it also from the involvement from the communities as well. So of course every entities in the society should take a role. That's why in my conclusion, everyone should take a role as agents of change. Okay, whether you are from school. Okay, that's why how do engage with the communities first from school and other communities like at many residential areas, to create a very simple awareness, and then how we can engage with communities through engagement with other, for example, with the other local authorities. So we collaborate with the local authorities, and then we create activities so that communities surrounding can join and participate in the event. Of course, it takes time, but inshallah, if we do something small and we have to think big out of these activities. So as a lecturers from a different fields, I agree with Dr. Lee, the moderator said that we have the resources, we have the facilities, so we should optimize the usage of all these resources and the expertise, so that the outcome will be something that can create values, particularly for the communities. Yeah, I think that's my answers.
All right, okay, thank you, Prof. All right, Ms.
Thank you,
Resti Nurmala Devi, do you have anything to ask? Because I
Yes.
can see that you put out your hand. Yes, okay, please.
Yeah, thank
go
you
on.
for the opportunity. So I'd like to ask regarding the economic feasibility study to convert plastic to be a value-added products. I mean, it is very nice prospects in the future, but what about in the economic sector? Would it be promising if some investor want to invest in this kind of business? Thank you.
Yeah, from the economic point of view, yeah, even though that I'm not really good in economic, but I will try to explain from the economic point of view. Because if we can implement this concept of the recycle, because some of the companies, they already implement this recycle, but the material that we use need to be some sort like have certain quality so that the material can be recycled. But in other aspects of innovation, that's why I've seen some of the countries like in African countries, they come up with the ideas of recycling, but that I haven't seen that it is in Malaysia, where, for example, they turn all this kind of plastic to, for example, pavement material for the pavement bricks. So it creates another good opportunity for the startup who involved in these activities, where the raw material come from the 100% of the waste, and then it creates another opportunities for the new startup, okay, to involve in this area where 100% consume waste material, for example, plastic, and then the product is a new innovations where it involves small manufacturing to solve some of the issues of this waste plastic. And I believe that some of the countries, they're really concerned about the waste as the waste recycle aspect. Okay, that's why some of the countries they're really concerned. The enforcement on the waste materials or waste material, whether from the household or from the factory or from the industries. Some of the they come up with the new circulations or new standards where some of the material, they have to be a few percentage from the recycling, and that we create values of the product that they produce. So actually for this economic aspect, the roles of the those who involved in the in this setting up the awareness, as well as the giving the economic aspects, should take aggressive effort to ensure that this recycled material can be implemented in many industries. In many industries, because some industries, particularly for example for the plastic, they know about the recycling, but some of the aspect is on the elements of innovations, because sometimes if you want to include a certain percentage of waste material, it will affect to the quality. That's why engagement or collaboration with certain institution, research institution, is very important, particularly if industry want to come up with a good quality product, and then at the same time can reduce the raw material usage by incorporating with the this waste material. So that's why collaboration between the industries and the universities is important to leverage the cooperation as well as to impact the economy, particularly for the towards sustainable product developments towards this innovation. Because if the industries they really bother about this raw material, which is from the main source. For example, when we talk about the polymers, okay, the main source is from hydrocarbon, from the petroleum process, okay, making this oil, and then they produce these hydrocarbon polymers. And we as for example, me as a lecturer, we have to create values from the ecosystem of the industries. So that's why it is important to have R&D section, where if let's say we want to incorporate with this kind of the waste material, we need to understand from the standpoint of the properties, the qualities, which is comparable with the one using the virgin materials. That's my answer.
Okay, thank you very much, sir. That's very awesome.
All right, thank you.
All right,
for your
okay,
questions.
thank you very much. All right, okay, Prof, maybe you can, okay, there's always a perception, all right? Okay, there's always a perception that by saying that when you are doing a product, when you are innovating a product, you are producing a product that is made from waste material. Okay, for example, maybe in this case, a face shield or the molding injection, the bookmark, right? They said that this particular product is not as lasting compared to product that is made from the natural
material.
sources. All right. Yes, virgin material.
Yeah.
And then another thing is that they said that if you have already made a product from a recycled item, that means this product cannot be recycled anymore. Okay, so these are the perceptions of the public. So maybe you can comment on this. All right.
Yeah, that's why some of the perception when we use the recycled material, people say that we have downgrade the qualities of the part. But actually, this give a good values for the some of the company when you do we use incorporate with the recycled material. For example, we can reduce costs of the raw materials by using this some amount of the waste material. But of course, the quality is a very good concern. When we talk about the, for example, the face shield, actually we are using the raw material from the polymer, so we have to take into consideration in terms of the qualities. Of course, it depends on the application. If an application that requires certain aspect, for example, it be, the costs of the irrigations, and then we have to consider that aspect. But of course, for the polymer, they have a different grades. The one that have a good quality normally it come from the good grades of the polymers, and then there are some level of acceptance of the waste material. That's why it is very important to create this awareness at wherever you are. Okay, that's why everybody should take a role. Okay, even though that we are at home, we can educate our kids. Okay, so don't throw away this plastic the food container. So look at the symbol. And then this number one, okay, so what is the melting temperatures? Okay, we have to segregate this plastic with the plastic waste. This I believe that we can create small things at home. Okay, even though that sometimes people say that this is not no point by having this, but I believe that because when we create this awareness at home, and then they still be nurtured with the elements of awareness at the beginning of education. So even though that is not official at school, but as a parents, with the knowledge that we learn, we believe that this element can be nurtured at home, and then the student can educate to other students and create, the platform like social media, Facebook, Instagram. Now we have TikTok. We can make a very simple video, short video about 1 minute. Okay, about don't throw away. Okay, just segregate. At least this is a campaign of awareness, right? Because the reason of some people give a different perception is because of they don't know more about the materials. Okay, so when we have gone through the process of, for example, we do the analysis, then we know that material can be recycled. Of course, there are a bit the quality will be a bit changed, but sometimes we can be improved by adding some modifier to improve the quality. So that's why, again, the roles of the engineers, the roles of the universities is to give values towards the ecosystem of the innovation.
All right. Okay. Thank you, Prof. Agree. It's like actually we all of us have to play our own role.
Yeah.
We need to take the first step. Only then we can do it.
Yeah.
Okay. All right. I think Mr. Jason Brian Susanto, do you have a question? I can
Yes,
see that you are you. All right. Okay. Yes, please, Mr. Jason.
Okay. Thank you very much. First, I want to check if my sound clear.
Yeah. It's clear. Nice.
Okay, thank you very much. Okay. Yeah. Recently, I read some news about the scientists that can convert plastic waste into vanilla flavoring. Yes, it can be a great advantage for us because we can reduce the amount of plastic in our environment. But there are still a lot of people that contradict about this because it can damage. They say it can damage Earth because it came from plastic. But I know it's no longer plastic. So what is your opinion about this? Thank you.
Yeah. Of course, when we talk about innovation, there will be pro and cons, right? There'll be a pro and con. But if you look at SWOT analysis, what the strength, weakness, what's the opportunities, and what's threat, right? So every innovation that we do, there will be a pro and cons. That's why as engineers, we have to come up, we have to do research. We have to do research how, when we have some difficulties, when we have facing challenges, how do we want to overcome it? So these are the roles of, as innovators. We need to improve. It can be the process. That's why innovation can be a process innovation. How we can improve the process so that we can get good quality. It doesn't mean that we can 100% completely change, the ecosystem, but at least we can be the agent for change, agent of change. So for me, every innovation they have advantage and disadvantage. Of course, when we talk about my innovation is talk about in recycle. We have to apply temperatures up to 200 degrees Celsius. Some people from the different angle, they say that, oh, this one, we consume energy, temperature we apply very high, that involve carbon footprint. So that's from another aspect. But we have to think about from the other angles. So when we bring these two elements together, for example, the issues of a carbon footprint. So how do you want to leverage this carbon footprint together with those who involved in this recycling awareness, so that at the end you can come up with a very strong justification from the different angle of, from the energy point of view and from the innovation point of view. For me, every innovation, they have pro and cons. Okay? We have to appreciate those who have created this innovation, and of course there will be a continuous effort. It's a continuous effort. It is not a one day innovation. Is not 1 year innovation. Innovation is a continuous effort. So for me, we have to appreciate every single values, and we have to support for every initiative. And of course, those who involved in this innovation, it study a lot. You study about the problem. You study about the problem associated, and then they come up with the new approach. Of course, when we study about the new approach, there will be another things, the what we call it as maybe a side effect, but this thing need to be studied by those who involved in the circle or the circles of these innovations.
Okay, thank you, Prof. All right, we have another question at the chat box. Okay, from Miss Dora Yit. It's heartwarming to see the 3D printing communities across the world are stepping in to help producing open source face shield. Doctor, in your opinion, based on your experience in 3D printing face shields, how to ensure the design, sterilization, production, fitting assembly, quality control that are safe for our medical frontliners?
All right. Actually now there are lots of face shield, right? During my first our face shield, we have sterilized all the parts before it is delivered to all hospital. So we have followed the very strict regulations. All the 3D printed part and all injection molded parts, we have gone through the process of sterilization. So we apply with some chemicals, then we dry it, and before we packing, and then we send it to the respective hospital and clinics. So basically, of course, because the material have a direct contact with particularly our forehead, and that's why it is important what the material that we use. Okay, what the material that we use. As long as the material, we have a certificate, which is the quality of the material is food grade. The material that we use is a food grade polypropylene. Okay, that has a very good quality one that's applied to us from Petronas. So I forgotten what is the questions.
Okay, how to ensure the design, sterilization, production,
the design. Okay,
fitting,
design.
assembly,
Okay.
and the quality control. Yes.
Right. Regarding the design, actually we got from the open source, and then we do some modifications. Okay, we do the modification from the. Actually, the design is at the beginning of the facial design. It was the design is not really complicated. It just is not a really complex shape. That's why it can be 3D printed. Okay, so because since it's open source, so everybody cannot claim that it's my design, it's our design, but there's our patent. That's why during our innovation, we inculcate the elements of innovation in terms of the IP, because IP have different type of IP, like intellectual property. It can be patent, can be innovation, utility innovation, trademarks. But the one that we secure is copyright. The copyright is in terms of not only the design, but we have engraved with the UiTM, and then the facial, which is the front, the PVC, the transparent film, which is we just use simple punches from normal for the cover for the reports, PVC film. So we just use a very simple concept because we want to ensure that it is simple to be used. But over the time, of course, there will be many design, and even now we can see the price also become cheaper and cheaper. During that time, during MCO, it's quite difficult to get the facial, which is with special design, and the cost was about that during that time one piece about 10 ringgit, about 10 ringgit. But now we can see various design of facial with the very unique design, and then like the one that I've seen, the cost for the one facial is about less than 2 ringgit per piece. So that's why the ecosystem, the design, and then how do we want to ensure what the technology that we use, that will another aspects in the process of innovation.
All right. Okay. Thank you, Prof. All right. Is there any other questions that you would like to ask?
Yes, Doctor.
Yes. Yeah. Who are you?
My name is Lawal from UiTM.
Okay. Yes.
Yeah.
All right.
Doctor,
Go ahead, Mr. Lawal.
Doctor, what are the software to be used for the simulation and also for the 3D printing?
All right. For the simulation, actually, for the injection molding, we need to know what is the getting. The important part is the simulation because the simulation can be one is on the process, and the second one is on the material qualities. So from the mechanical point of view, if let's say that when we have design, we want to see what is the deflections, or what is the critical stress. So when you talk about the facial, the critical stress, the critical point is the point where from the forehead to this area. So when we bend the material, okay. So one of the issues of the 3D printed material, because PLA is very brittle. So in many cases, when we bend the facial, it will break at least 2 points. However, for the injection molding, owing to the good quality of the material, which is a polypropylene, the material can bend successfully. Okay, so that's one of the uniqueness of the material. So in terms of the simulation, for the injection molding, the simulation can be done through there are quite a number of software available, some free software, but some we need to have a license software. For example, in UiTM, we have CAD mold software to simulate the behavior of the molten material that goes to the cavities. So during the simulation, we can identify the critical point, the location where probably that create a defect, such as seeing marks and everything. So as engineers, we have to know the location of the gating. Where is the best location of the gating? So that's a simulation of the process. The second simulations of the, simulation for the injection molding can be done using the one that we have in UiTM is CAD mold. Some of the commercial software like mold flow. There's a common software used for the processing of injection molding. And then for the integrity of the material components, normally we can use common software like ANSYS. Okay, we design and then we just apply force, apply on it, and we can see what will be the critical stress. Normally it is measured by the von Mises stress. And for the 3D printed part, also the same in terms of integrity. But for the simulation, there's no such simulation for the 3D printing software. I'm not really expert on the 3D printing because we just use the simulation in terms of the way how they print using the software Cura. Okay, and yeah, in terms of simulation, that's for the 3D printing and injection molding. Because in terms of the nature of the process, both are different. For the 3D printing, there's no mold, okay, because it's a free form. It's a free form, but it's a time consuming. Just imagine one face shield, we can reproduce at least half an hour. For the injection molding, for one piece, it takes about few seconds. One day we managed to produce at least 700. The maximum, the highest amount of the face shield that we can produce in one day is 1,500 pieces. Okay? That's one of the uniqueness of the process of the injection molding. Capability in producing in mass production. Right.
All right. Okay. Thank you, Prof. Okay. Is there any other questions? Maybe one last question. Anybody? Okay. So maybe I think we are approaching our end of the session. So before I return the floor to the organizer, I would like to invite Prof. Hussain to have maybe one or two words just to tell the participants or anything.
All right. I would like to take this great opportunity to thank for your kind attention towards this my sharing on the ideas of innovation, particularly on the recycling of plastic. We look forward for if they say that we can collaborate in terms of activities, if not through webinar, it can be through physical. Yeah, I'm looking forward for this kind of the collaboration, and there's a good opportunity for this webinar series where we can communicate all around the world, okay, sharing some insight on the different angles or different perspective of research and innovation, and hope that we can be a agent of change, even though it is a small, but we have to think the bigger aspect, which is it may help to nurture the elements of creating a better world. We can start small, start from at home, okay? Educating our kids, our family members, and leverage the whatever opportunity that we have. For example, from different institution, so optimize the facilities and the expertise that we have for the creating more values towards ecosystem of innovation. I think that's all for me.
All right. Okay. Thank you very much, Prof. Okay. So please, everybody, now that we know that all of us, we actually have to do our part. Okay. Don't say that the role of having to make the world a better place only belongs to the government or only in the responsibility of certain people. No, actually, it belongs to all of us. It is our responsibility to start the baby step, to make the first step, to make the changes. All right. Okay. So I've already attached a link at the chat box for your quiz. Okay, very simple quiz. You have 10 questions and you have 1 hour. Okay, you are given 1 hour to answer the quiz. All right, so I think basically we have approaching the end of our session. So I would like to thank the panel. Thank you very much. And I would like to give the floor back to the organizing committee. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Dr. Hussain for the session and Dr. Linda as the moderator. We really appreciate you for today's session. We hope that everybody here learned a lot of things, gained valuable insights from Dr. Hussain. All right. This is the end for today's session. To participants, please do not forget to do the quiz, and I will send the feedback forms soon. All right. You have 60 minutes to do the quiz. Okay. So please take your time to do the quiz, and thank you, Dr. Hussain and Dr. Linda, for this session.
Thank you very much for the opportunity.
Okay. All right, thank you very much. Have a good day. Bye. All right.
Thank you. Have a good day.
Have a good day.